Hey everybody, welcome to my YouTube live. I'd like to thank everyone that signed in today for joining. I'm gonna turn this camera off. All right. So today's topic is, what are you doing to strengthen your immune system? And so we're going to go over some things about immunity, how it's built, a lot of interesting things. So I'm just going to wait like another second for people to log in, then I'll get started. Hey, SS. Can you guys hear me okay? All right, so a little bit about myself. For those of you that do not know me, my name is NADIA RUFFIN, and I'll just give you a little background about what I do, how I got to where I am. My education, I have a bachelor's in agriculture. My focus was animal sciences, and I got that from The Ohio State University. I also have a master's in entomology. My focus was medical and veterinary entomology, so I was very interested in insects that actually cause disruptors that cause disease. So it's like mosquitoes and ticks and things like that. But I have a master's in entomology. So I'm an entomologist, I'm an animal scientist, I'm a scientist, and then I'm a researcher and also an educator. I'm an owner of a urban farm here in Cincinnati called Quiwi Produce. I'm also co-owner of a new lab venture that I'm starting, and it's called Academy Labs. I'm founder of Academy Incorporated, which is a nonprofit organization where we do agricultural research as well as outreach in the community, trying to get more socially disadvantaged people interested into the agricultural field. So what I do here in Cincinnati now, I'm an urban farmer. I grow things on my farm. I have an empty lot that I purchased, and I actually converted into a farm. So I grow things in hydroponics. I also grow in the soil. I teach classes. I own chickens, and I have bees and things like that. For this actual presentation, it's going to focus on when I was actually a disease investigator with Hamilton County Public Health. That's located here in Cincinnati, Ohio. And I'll get into more specifics of what a disease investigator is in a second. I also have experience in floriculture. My family has owned a flower shop here in Cincinnati for about 42 years. During my college career and before I started actually doing just the the urban farming and things like that, I used to do a lot of research. I worked at a lot of different labs. Some examples where I worked at University of Georgia, and I worked in wildlife disease, and I was testing deer for chronic wasting disease, which is a prion disease. So we had to test tissue samples that came in for this disease, and if we actually found it in a certain area, the deer in that particular location would have to be eradicated, because this disease is very life-threatening to other deer, and so you have to get rid of them in that area. Also, I worked at the Ohio State University in oncology, as well as some bacteriology labs and things like that. I've worked at University of Cincinnati, and I've worked at the Ohio Department of Agriculture. All right, so for today's outline, we're going to talk about public health a little bit, talk about what a communicable disease investigator is. We're going to talk about what is immunity, the difference between innate and adaptive immunity, We're going to talk about some things that can help your immune system during an attack. And we're going to talk about anthocyanins and antivirals. And we're going to conclude, and then we're going to talk a little bit about Quiwi Produce, the online school that I have. And if you guys have any questions at the end, you can also ask questions as I'm presenting. But definitely at the end, I'll answer questions if you have them. All right, so public health, tracking diseases. I don't know if you guys ever heard of epidemiology, but epidemiology is the branch of medical science that investigates all the factors that determine the presence or absence of diseases and disorders within a population. So I used to work in the epidemiology department at the Hamilton County Public Health, and I was a communicable disease investigator. So basically what I did is I reported non-STD diseases and outbreaks to the state health departments. I also investigated disease outbreaks in institutions and in the community. I called in prescriptions for people that may have had one of those reportable diseases. I also responded to foodborne illness complaints. This could be at restaurants, or when like when Chipotle would have people would get sick. I would have to respond to those type of things, and we have to figure out people that were sick, what they had eaten, and things like that. We had to do a whole investigation. Also, when it was food recalls for Dole and those types of, when lettuce was contaminated and they, we might have had cases in our area, I would have to respond to those outbreaks and those complaints and those, things. And so I had to make sure that people were getting tested. If they were in sensitive occupations, they couldn't go back to work until they were not having symptoms and they had negative test results and things like that. So I had to monitor those types of things. So I also provided literature and educational materials to doctors, schools, hospitals, anybody that needed information about a disease or an outbreak. I was there to provide that information for individuals here in the county. So what is immunity? Well, immunity is, first we're going to talk about what's immunology. So immunology is the study of the immune system, and it is a very important branch of medical and biological sciences. Basically, the immune system protects us from infections through various lines of defense. So we have what is called an innate response, and we have what is called an adaptive response. This is called innate immunity and adaptive immunity, and we'll talk about that right now. So your body has been designed to defend itself against diseases. The immune system is composed of special cells, proteins, tissues, organs that aid in the fight against invaders. So some of those organs are like your skin, your thymus, your tonsils, mucous membranes throughout the body, your appendix, your tears, your saliva. Your body is equipped to actually fight off disease. So immunity is a multi-layered system. It's not something just simply you go and you eat something and it protects you. No, there's a system that has to go in place when the body comes under attack. And so the immune system can be divided into two types of defense systems. The first one is innate, which is non-specific, and this includes physical barriers, and this also includes internal defenses. The second is adaptive or acquired, which is specific, and this could be active immunity or passive immunity. This can be natural or artificial, and we're going to go through all of these. This is a little chart to explain it. So there's immunity, like I said, there's adaptive and innate, and then that breaks down further. So I have this little chart here, and we're actually going to go through each one of these. But basically, there's 3 lines of defense that your body has to go through before immunity is actually established. There's external defenses, there's internal, there's active, and then there's passive. So your first line of defense is physical barriers. These are non-specific. So an example would be your skin is a physical barrier. It's covered with oily and acidic. pH of your skin is usually around 3 to 5. It's the pH level. You have secretions like sweat, lactic acid, and things like that actually help you fight microorganisms that may, somehow get in contact with your skin. So your skin is always going to be your first line of defense. Antimicrobial proteins or lysozymes. These can be found in saliva. They can be found in tears, mucous membranes. So mucous membrane, it lies right underneath your skin. They produce mucus, and mucus is very important when it comes to helping trap disease and microorganisms and actually, getting them eliminated from the body. So mucus is very important in the body. Cilia, these are like tiny little hairs. You can find them in the lungs. And what they do, especially in your lungs, is they keep, dust and microorganisms from actually getting down in there. They kind of like sweep. And then there's mucus that's in your lungs that actually traps them. And then when you cough and things, that can actually help eliminate microorganisms. Gastric juices in your stomach, so your pH is 2, and this can kill most microbes. So when you're eating something, and say there's microbes present, for the most part, most microorganisms cannot survive that pH. Now, if that microorganism produces toxin, that's a different story. Some toxins can survive, a low pH. They can survive, high temperatures and things. And so that's a lot of times what makes you sick is the actual toxins that some of these microorganisms produce. There's also symbiotic bacteria. So these can be found in the digestive tract, in the vagina, and they outcompete pathogens and organisms. So like in your digestive tract, when they talk about probiotics, these are the microorganisms that actually fight foreign microorganisms that may be in your gut. So you have this first line of defense. It's non-specific, but it's very powerful at making sure that microorganisms do not take over your body. So if they get past all of that, then you have the second line of defense, which is internal defenses. So these are non-specific cell receptors. These are things like phagocytes. Say you cut your leg or something, and you have inflammation in that area. That's all a secondary response to an attack. A fever. Fevers are very important. I know every time someone gets a fever, we want to rush and give a person, like Advil or ibuprofen to lower the fever. But the fever is actually an innate immune response to your body. Your body heating up, those microorganisms cannot live in that high temperature, and so it's helping to actually kill them. So, giving medicine to lower fever, we're actually doing more harm than we are good. That fever needs to be there to actually, kill some of those microorganisms. The problem is that if the attack is really bad, sometimes the fever can get too high, and then it starts destroying your own cells as well. So you have to monitor a fever. But if it's like in the 101 and 102 range, you're probably okay. Now, if it starts getting up to like 103, 104, 105, then you might want to be a little concerned. There's things like cytokines. These are actually chemicals that send messages to other cells inside the body that a foreign bacteria or a virus is present, and it sends it to those cells so they can start going to that location and actually attacking wherever those microorganisms may be. There's also antimicrobial proteins, and there's natural killer cells. And again, they actually communicate with these cytokines and your other phagocytes and things, and they are triggered to say, like, okay, I got to destroy this cell because it's been infested with, this microorganism. So adaptive immunity. This is the third line of defense. So if the microorganism was able to get past the first and second, your body still has this third one. Active immunity occurs after contact with an antigen and the antibodies produced inside the body. So some natural active immunity are when your T cells and your B cells are activated, and they actually act upon an antigen that's on the surface of, say, like a bacteria, or it's on the surface of a virus. An example of artificial active immunity is vaccines. So a vaccine, in theory, is supposed to contain an antigen, or it's supposed to contain a pathogen, but it's not able to, proliferate inside the body, but it's supposed to trigger that immune response to where your body will produce those antibodies. That's in theory what vaccines are supposed to do. So I'm not going to really get into specifics of should you get vaccines or should you not get vaccines. I'm just trying to give the science behind why vaccines were initially created. But this is active immunity. That means that an actual pathogen has come into the body. Your body has gone through all of the first, second, and now we're on the third line of defense. And this is where your body was going to create the memory of actually, fighting off this infection. And so if you ever encounter it again, it's supposed to identify it and then, fight it off. So passive immunity is the other side of passive immunity. Is when a patient has no direct contact with the antigen, but they receive antibodies. These antibodies are actually produced outside the body. So a natural passive immunity is when antibodies are transferred between mother and child via the placenta, or when the antibodies are passed from mother's milk when a child is nursing. An artificial passive immunity is when antibodies are donated from another source. Say you get tetanus, this is a good example, and you have to go and get that injection. It's called immunoglobulin injection. What that injection has is actual antibodies for tetanus bacteria. It's not like a permanent fix, but it'll initiate that initial response that your body needs to attack this this foreign bacteria, and it needs to attack it and things like that. Eventually your body will build up that immunity, but you may also have to still get that tetanus shot to actually still trigger those antigens being present, so your body knows next time that tetanus is present, that it needs to attack it before it can actually divide and replicate and reproduce itself and cause infection. So anybody have any questions? All right, overall, your immune system does a remarkable job of defending you against disease-causing microorganisms. But sometimes it fails. A germ invades successfully and makes you sick. What could you have done to prevent this? The answer is your body can only build immunity by exposure. Go ahead, Kay Mondal. What's your question? What's your question? Okay, well, I'm just going to go and then I'll see your question. I'll answer it. Okay. Hold on a second. So Kyra Barr has a question. She wants to know, how long does it take for the body to heal from the illness once you are exposed to the pathogen? In all actuality, like when a person gets the flu, it usually takes 14 to 21 days for the body to actually recover from actually being, infected with the flu virus. That solely depends on the pathogen that's present. Also, it depends on the person, their age, their health, and things like that can affect how soon a person actually recovers from a pathogen. Some pathogens, they can lie dormant and then they can reappear and things like that. So it solely depends on the pathogen, but then it also depends on the person and their immune system strength and things like that. Okay, so when the body is exposed to a virus, a bacteria, a fungi, or a parasite through an infection or through a vaccination, the immune system creates antibodies and the immune cells that inactivate or destroy the specific infectious organism. If we encounter the same organism in the future, the immune system should remember that previous exposure and it can mount a vigorous defense attack. All right, but there are things that can affect your immunity, and I was just touching on this when I Kyra when I answer her question. So immune function can be affected by many things. Age is one. Usually, really young people or really old people are the ones that are usually most susceptible to a lot of diseases. The reason being, when you're really young, you haven't built up any immunity because you haven't been really exposed to a lot of stuff. And when you get older, what happens is your immune system starts to break down. It starts to forget, it had been exposed to things, especially if you hadn't been repeatedly exposed. Also, when you get older, just your cells and things start to slow down and all that. So age plays a big factor. Genders are some things that women are more prone to getting versus men, and gender plays a role in that. Genetics as well. Early life events. If you were born and you were already immunocompromised when you were born, most likely you're not going to have a strong immune system as you get older. And so you're going to have drugs and things incorporated to actually protect you. Nutrition plays a big part in this as well. You have to be eating right. And I can add in here exercise, controlling stress, smoking, alcohol, all that, a lifestyle contributes to your immune system. Stress can be environmental, physiological, and psychological, but it can affect your cells that, will actually fight off infection. Also, your exposure to pathogens. This is where the immunity is actually going to be built. You have to be, infected a lot of times with some of these things for your body to actually build up that immunity. Also, they tell people to wash your hands, you want to be clean and things, but a lot of times we're so clean that we create a environment in our bodies where we haven't been exposed to anything. So we're always going to constantly be sick because we're never exposed to anything because we're too clean. So it has to be like a happy medium. Like, you got to catch some stuff, but other things you don't want to catch, especially if it's something that we don't have a cure for or whatever. But the only way your immunity is going to be built is to actually be exposed. Yes, stress does lower the immune system. Vaccination history. Measles, things like that, your body should remember that it had that vaccine, and it should, if those, pathogens enter into your body, it should elicit that response that, oh, we've seen this before, even though we saw it via vaccine versus, actually having those infections, it should elicit that response that your body should start attacking those pathogens as soon as they come in. Obesity, again, that's a lifestyle that can also affect you. If you're not healthy, you're not active, you're not moving, you're gonna, your immune system's gonna suffer. You have to have, active lifestyle. You have to have good nutrition and things like that to actually maintain a good immune system. And the last one we'll talk about is hormones. So things like diabetes, those are hormonal type chronic conditions and things. Hormones can actually, affect things like T cells, B cells, things like that. Also, if you have certain diseases or, you're getting treatments that can cause immunocompromised system, things like HIV, if you're getting chemotherapy, that can totally destroy your immune system. And so you're not going to be able to fight off infection very well if you don't actually even have a functioning immune system. So what can help your immune system during an attack? There are certain antimicrobials that can be administered to help your immune system fight off microorganisms. So these antimicrobials are antibiotics or antibacterials, antivirals, antiparasitic agents, and antifungals. So antiparasitic agents would be those that fight off things like cryptosporidosis, which is a protozoan that causes diarrhea and it's found in water. Giardia. There's antiparasitic agents that you can use to actually fight these off. Some of these are naturally occurring, and some of these are, synthesized in labs, and they're made into actual pharmaceutical medications and things. But these are things that are used to fight off these microorganisms when your body needs a little help because it's, this organism has went past all three of your defenses. So food contains many antimicrobial agents that can help your immune system fight off infection. So there's plant-derived compounds, there's animal sources, and there's microbial. we're going to focus tonight on just the plant-derived compounds. So we know plants, they produce all types of chemicals and oils and flavonoids and all types of things. And, the plant produces it for itself so they can survive, but we found that if we consume these plants, they contain these things that can actually be beneficial to us because we consume them. Do you need sunlight also? Yes, sunlight plays a vital role in vitamin D, and vitamin D does play a role with the immune system. So yes, you do need sunlight as well. People take vitamin D3 tablets, but nothing is more effective than actual sunlight. I mean, you can take that and you'll feel good, but it's better to actually get sun exposure. All right, so we're going to focus on antivirals. Now, plants, they do have antibacterial, and there's some plants that have antiparasitic and antifungal properties, but we're going to focus on the antivirals because we have a lot of viruses right now circulating in out in the communities, pretty much out in the world right now. Cold, flu, and the coronavirus, the COVID-19, these are all viral infections. There are many plants that exhibit antiviral properties. Everybody always talks about elderberries around this time of year. This is a great example, but why are elderberries so effective? Well, they contain a flavonoid called anthocyanins. Now, I know, and the reason I want to go over elderberries because elderberries are talked about every flu season. They're talks about why they're what they are. So anthocyanins are a group of naturally occurring pigments that are responsible for the red, blue, or that purple color of many grains, fruits, and vegetables. They are associated with many health benefits, one being that they are antiviral. So I'm going to talk about anthocyanins as they are inside of elderberries, but they're in the form called anthocyanidin. And anthocyanidin is just a derivative of anthocyanin. What happens is you take off a glyphosate group off of there, and you add a hydrogen and you hydrolyze it, and so it turns from anthocyanin to anthocyanidin. Can you all hear me okay? So elderberries and their effect on influenza. Influenza is actually the flu. That's the technical name for the flu. Elderberries' antiviral activity can be attributed to its anthocyanidin compounds. In a study conducted by researchers from the University of Sydney's Faculty of Engineering and IT, in lab, what they found is that anthocyanidins bound to healthy cells, and it prevented flu virus from entering into those cells. Anthocyanidin also bound to infected cells that actually had flu virus inside of them, and they found that this compound was actually able to prevent the virus from being released from that cell, and so it was not able to cause further infection. And so they were really amazed because what happens is when the flu comes into the body or when a virus comes into the body, what it does is it invades cells. It invades healthy cells, and what it does, it takes that cell's DNA, it replicates its own either DNA or RNA. In this case, flu is an RNA virus. It takes its RNA and it replicates itself inside that cell, and then it'll lyse that cell and it'll release all these new viruses that were produced inside of there. What they found is that the chemical compounds in these anthocyanidins from these elderberries was actually able to prevent that from happening, and it prevented healthy cells from even being invaded by those actual flu virus. So while elderberries exhibit this antiviral property, there are numerous other anthocyanin-rich fruits and vegetables that also exhibit these same characteristics in labs. There are numerous studies that prove this. The more anthocyanins, the deeper the purple color a fruit or vegetable has present, the better antiviral properties that particular fruit actually would have. So I have the study listed here. There was one, but there was about 5 that I know of, and I'll post some of those on my wall so you can actually read them. They are scientific journals, so there's a lot of big words in there. If you don't understand, you can just look the words up what they mean. But basically, we're saying that, you know, fruits and vegetables that are rich in these anthocyanins, they're actually very effective at being antiviral. And they found this in lab. They didn't actually do any studies in actual, you know, like rats, mice, or even humans, but they found that in lab that these particular chemicals were able to prevent virus from entering into cells. And so, you know, elderberries is one berry that's been used for, you know, centuries by people. They would go and collect them and they make, you know, medicines with them. And they noticed are rarely got effect. They recover, but finding that there's other dark colored fruits and vegetables that could be just as effective. What about bitter greens like turnip and mustard? Yeah, if they have that purple pigmentation in them, they have those anthocyanins in them, and so yes, they would be a good source of anthocyanins. So I have a list here. It's kind of hard to see, but it lists things like blackcurrant, eggplant, blood oranges, blackberries, blueberries, raspberries, cherries. All of these have high levels of anthocyanins. All these have high levels of anthocyanins, and they're all purple. And so, you know, just because the elderberries are very effective, these other things are probably going to be just as effective as well because they have the same level or more anthocyanins than, you know, the elderberries themselves. So if you're ever like cold and flu season, you can't get elderberries or you can't get a solution. I don't trust now that, you know, pharmaceutical companies have caught on to the fact that elderberries are a source of antiviral and they're creating like these cough syrups and stuff, but they're adding other things into there. It would be better off if you just went and got the fruits yourself and made your own. And there's recipes on how to do that. Only thing with elderberries, you have to make sure they're ripe, because if you're not ripe, they can be toxic. So you need to be careful with them. But if you can't get access to elderberries, you can get back access to other things like blackcurrant. This one berry called chokeberries. They have a really high level of anthocyanins, but also like purple bell peppers, some brassica plants, purple carrots, eggplant. The skin of the eggplant actually has a lot of anthocyanins in it. Purple cabbage, things like that. So there's other things out there other than elderberries that have these same, you know, chemicals that are actually effective against viral infections. So it may be to your advantage to consume foods high in anthocyanins during cold and flu season, or anytime they're talking about there's a lot of, you know, viral infections going around. They also have some other medicinal properties, but these seem to be the main ones that they're focusing on right now because of, you know, we have cold and flu season. Now we have this COVID-19 coronavirus. We have other stuff going around that's viral. So it might be better for you to build your body up consuming these anthocyanins and, you know, make sure you're exercising, make sure you're not smoking, drinking, things like that. And that will actually help strengthen your immune system. So, in conclusion, immunity is built through exposure. There are many factors that can affect the overall function of your immune system. There are things like antimicrobials that can be used to help your body fight off an infection. Yes, COVID-19 is just another name for the coronavirus that's circulating right now. So I want to talk about a little quick about Quiwi Produce Online. If you would like to watch my recorded webinars I did about coronavirus and influenza, you can visit my school website at www.kiwiproduce.farm/school. I did a First, I did a webinar on coronavirus, so it explains coronavirus, it explains public health, how those viruses and how those diseases and things are reported. And then I did the same thing for the actual influenza, because influenza is actually worse than coronavirus. We're probably up to somewhere between 20,000 to 40,000 people that have been killed by the flu virus just this season. And nobody's really putting a big focus on influenza. We're only focusing on coronavirus. We do have deaths, but they're not nearly as high as the influenza. Also, there's been millions of people that have contracted influenza. It's not nearly as many cases of coronavirus. I know the numbers are climbing, but influenza right now is reigning supreme at, affecting people's lives and things. So if you want to watch those webinars, the price to purchase them is $10. I also have other webinars and online classes available for purchase on there as well. So if you guys have any questions, I know you were asking viruses or anything like that, or, the immune system, was this helpful? Just let me know. Give me some feedback. Well, if you don't have any questions, you can always put them in the comments. Or you can send me an email at urbanfarmsister@gmail.com. Oh, I didn't put my email on here. But yeah, or you can find me on social media. I'm on Twitter, Facebook, YouTube, and Instagram under Urban Farm Sister. What about things like zinc and vitamin C? So Nick Townsend has a question. She said, what about things like zinc and vitamin C? Yes, those things help with the immune system as well. Some of those things like T cells, some of those proteins, they require those actual, in this case, zinc is an element to build its structures. Vitamin C, it contains ascorbic acid and things like that, which are utilized by the body to actually synthesize many of those proteins and many of those, defense mechanisms like the structure, the cytokines and things like that. So those things are important. But people always talk about, you got to boost your immune system, boost this, boost that. You're not really boosting it because you're not making more cells. The only thing that makes more cells is that a microorganism comes in there and triggers your body to make that. Does anybody else have any questions before I log on off? All right. Well, thank you guys for joining. Like I said, if you have any other questions, you can always put them in the comments and I'll answer them when I get them. And I thank you guys for joining this evening and have a good evening. All right. Talk with you guys later. Bye. Oh, you're welcome, Kyra.